Hello, so this is my project on exploring different data visualization tools and scikit-learn classification algorithms. My goal is to create a machine learning model that can classify different species of irises based on a set of features. Here I've included some links to blog posts that I loosely based this project on. Starting with data preparation, first things first, I'm going to import the iris dataset from the scikit-learn library. So after running this code cell, I can see more details about the dataset and how the data is stored. Here I see that there are 3 species of irises in this dataset, and 4 features that I can use to classify them, namely sepal length, sepal width, petal length, and petal width. Next, I create a timeless data frame from the dataset. This isn't necessary for creating the machine learning model, but it's helpful for getting a sense of what the dataset is like. On to data visualization. Running the name of the dataset outputs the first 5 and the last 5 lines so I can make sure that the data was formatted correctly. Next, I check how many of each species I have. From the output, I can see that I have 50 data points for each species. Here, I use the seed-born library to create a pair plot. Okay, so this is what the pair plot looks like, and from the pair plot, I can figure out what the relevant relationships between different variables are. Here we can see that features like petal width and petal length, this graph right here, they may be good teachers for differentiating between species because they are well separated. The last thing I do for preparing the data is splitting the dataset into testing and training sets. I do this so that I can check the trained model's performance against the testing set later on. Here, I split the dataset into training and testing sets in an 8:2 ratio. So on to choosing and training a model. Using the training set I created, here I will try a variety of classification models from the scikit-learn library. Specifically, I'm trying the k-nearest neighbors algorithm, the decision tree classifier, and the stochastic gradient descent classifier. And now we're on to evaluating the performance of each classification model. The first method I use for evaluating performance is using classification accuracy, which compares the number of correct predictions to the total number of predictions. Here we can see that the k-nearest classifier algorithm provides the greatest accuracy of 100%. The second method I use is using a classification report. This method provides more info than just the classification accuracy, as it provides the precision, recall, F1 score, and the support of the model. So running each code cell here outputs a classification report for each algorithm. Note that retraining the model and re-evaluating performance can show slightly different results as there is a bit of chance involved in the training process. So if I rerun everything right now, so let's just look at what values we have right now. So if I rerun everything, we can see that the values changed from before, although k-nearest classifier still came out on top with the highest accuracy.